Hello, old sport. I'll be very impressed if someone can guess what Halloween costume I am. We're going to do proportions now. I'm going to try this out. I'm going to teach and also be up there teaching. So we're just going to see how this works. Okay. Now, in this proportion means two ratios, two comparisons of quantities of things. The way that we can solve for x here is by multiplying 3 times 5, I'm going to write it here, and then we're also going to multiply the 4 times x, and write it here, and this here is a much easier equation in which to solve x. We have 3 times 5 is equal to 4 times x. This 3 times 5 is equal to 4 times x. So this is what we'll have. 3 times 5 is equal to 15. 4, and then we have 4 times x, 4x. We have a one-step equation. Divide by 4, and x is equal to 15 over 4. And that's my answer. Okay, going down now. Here it gets a little bit more complicated because of the fractions, but we're still going to multiply this one here, 11 times x, and that's going to be equal to 4 times 2/5. Okay, so now we have 11x is equal to, when I'm multiplying by a whole number by a fraction, I'm going to have to write that whole number as a fraction. So it'll be 4 over 1 times 2 over 5. I don't need to flip it because it's not dividing. So I've got this now. 11x is equal to 8 over 5. And now here, I've got a one-step equation. I'm going to isolate the x, do the inverse operation. So I'm going to be dividing by 11. What I do to one side, I also must do to the other. So this is what we have. Actually, I'm going to write this in a different color. Divide by 11 here and divide by 11 here, which would give me, I'm going to write it up here, x is equal to 8 over 5 divided by 11. We have 8 over 5, this fraction right here, divided by 11. So here, 8/5 divided by 11. If I want to divide fractions and whole numbers, I would have to write the whole number as a fraction, something over 1. Take this turns into 8 over 5 times, flip it, 1 over 11, which gives me 8 over 55. Now, a lot of you I know like to use decimals because it, I think makes a little bit more sense, but this would have been an absolute pain with decimals. This is 0.4, that's not too bad, but this right here turns into 1.6, multiplying 1.6 times 1/11, which is about 0.9, and it kind of goes on. I think it goes on forever. It's a rational number, but it goes on forever, so it's going to be a pain. Fractions, it's still multiplying whole numbers, really, but you just got to figure out, when to flip, which is dividing fractions, and then multiply straight across. So it's going to be a lot easier. Okay, now we're going to go to the next problem here. I'll give us some more room. Okay, we've got 1/2 over 4 is equal to 2 3/4 over x. Seems a little bit complicated, seems a little bit daunting. It's not too bad. What we're going to do, multiply the diagonals, so it's going to be 1/2 times x is equal to, and then these here, 4 times 2 3/4. Okay, so now we just have to use all of our fraction rules. This here is going to be 4 times, I need to turn this mixed number into an improper fraction. So 2 times 4 is 8, plus 3 is going to be 11, and it's still over 4, 11 fourths. I'm just bringing everything else down, one step at a time. 4, if I'm multiplying fractions, I need to have the whole number as a fraction, so it'll be like this. So now 1/2 x is equal to 44 over 4. Well, that actually turned out nice. They didn't intend for that, but it's pretty nice. 1/2 x is equal to 44 divided by 4 is 11. And now what we'll do, this 1/2 is being multiplied by the x. What I could do this and think of this in 2 different ways. I could multiply both sides by 2 over 1. But it's actually going to be the same thing as if I divide both sides by 1/2. Because if I divide both sides by 1/2, over here it's eventually going to be flipped. But we can do it this way here. Multiply both sides by 2 over 1. I'm just doing the operation that is necessary to isolate the x. These will cancel. X is equal to, let's write 11 as 11 over 1. Multiply it straight across, 22 over 1. X is equal to 22. Okay, now these are important because these include conversions. And this right here is the homework problem. Jose has a piece of candy that is 10 centimeters long. He wants to give it to his friend, but he said he wants to give it to his friend, but the friend said he had to convert the centimeters into inches first. Convert the 10 centimeters into inches. Okay, and we're given, this is important information right here. 1 inch is equal to 2.54 centimeters. 1 inch is equal to 2.54 centimeters. Right here, this is a ratio. That is a comparison. So this is what we could do. We could have 1 inch over 2.54, have everything aligned. Now, we're trying to find how many inches are in 10 centimeters. So what we can do here is multiply these. 1 times 10 is equal to 2.54 times x. So now 1 times 10 is 10, and we have just a one-step equation. Divide both by 2.54. This cancels, and then x is equal to 10 over 2.54. To save time, I'm going to leave it right here. We've isolated x. X is approximately, this squiggly equals means approximate. 2.4 goes into 10, approximately 4 times. You're going to have something like this. The quiz question will probably be give the expression necessary to solve for x. Okay. Next problem. Measuring unit is used by pharmacists is the dram. 8 drams are equal to 1 ounce. This is a comparison. How many drams are in 60 ounces? So we have 8 drams is equal to 1 ounce. And how many drams here, keep everything aligned, are in 60 ounces. So we could do our method of our unit rates, but we can also, this is I think a little bit easier, you just multiply and then solve for x. So 8 times 60 is going to be equal 1 times x. 1x is just x. 8 times 60 is 480. We got it, 480. I kind of stopped something. I was expecting there to be one more problem. There isn't. All right, that's it for proportions. Make sure to multiply here, set them equal to each other, and solve for x. Oh, and Mr. Corbett, 3, 2, 1.